Hello, everyone. Welcome to our session. For today, you are going to learn the most common linear data structures in the field of computing, which is stack algorithm. It has actually influenced a lot of modern applications in today's generation. So at the end of the lesson, you are going to learn the definition and importance of stack. Second is you are now then going to identify what are the basic operations of the stack. And then after knowing the basic operations of stack, you will now then implement them in a program. Basically, we are going to create an ADT out of the algorithm of stack and then implement them in an array-based data structure using a certain programming or a programming language. So for this, we are going to use Java language. And then the fourth one is we are going to examine the application of the stack algorithm. So when we talk about stack algorithm, this is actually called as a last in first out algorithm or LIFO. In other books, it's actually called FILO or first in last out algorithm. So when you talk about LIFO algorithm, it means that when you insert data to it and even remove data to it, it's always going to happen at one end, which is called top. Okay, so I would just like to elaborate whether you insert data or remove data from the tab, it's always going to be happening at the top. Okay, so that's why it's called last in, first out algorithm. Some of the examples of this are a stack of coins, stack of dishes, stack of books, and many more. Like for an instance, we are going to add or insert, add data or add books to this stack of books. It's going to be added at the top. And then when you are also going to remove a particular, you are going to remove this stack of books. Also, it's going to happen at the top. So that's actually the nature of stack algorithm. So why do we need to study stacks? So there has been actually a lot of applications that has been applied to or have been or yeah has been applied to in many modern applications today. But these are some of the applications that Stack is mostly or most common, which are reversing data, parsing data, postponement data usage, and backtracking steps. Now we shall go over them one by one. So here in the reversing data, uh, from here we have actually I had actually given you a parang like a program where you determine whether an entered string is actually a palindrome or not. It's it's going to be a palindrome if after reversing as a particular string, if it's the same with or if it's the same with the original value, meaning when you get to compare it, it's of the same value or the same sequence of characters. So meaning it's like nothing is seems to happen upon reversing a particular data or a particular string. So that's where you know, that's when you know that a data or an enter string is actually palindrome or not. So basically, you reverse the string. Either it depends on your algorithm or it depends on the algorithm you have applied. Either you start at the last character and then going through or traversing, going through the first character. And then every time it actually iterates now using the loop, you are now then going to concatenate where this particular character to a string and then compare it to the original string. So you can actually do that. In a similar manner, you have here like if we are going to reverse a list of numbers, okay? If this is like let's say if this is in Java, there are two ways on how you actually reverse this particular data. If it's entered as a string value, you can then actually visit, I mean, you can actually use go directly from the last or at the last part or at the last value of number and then visit going back and forth, something I back going back to the first one. So that's like visiting five and then 4, and then next is 3, then 2 and 1, and then you're able to actually reverse that. Or a certain algorithm must be like can be actually followed. Another way of solving it is by dividing this one to, I guess it's like 100 or something like yeah, it depends on the digits. Yeah. Another is in decimal to binary. So in decimal to binary, you'll have to follow the certain algorithm, which is by getting the remainder, and by the upon getting the remainder, I mean the only way for you to get the remainder is by dividing the value, or that decimal value, to 2. Okay, and then you just have to get the remainder by dividing it by 2. So which yields to always zeros and ones, either zeros and ones. Now, so that you're able to to stop the loop, you'll have to divide the value by 2, meaning it decreases its value until such time you arrive the zeros, 100, something like zeros and ones values. Now, upon arriving the zeros and ones values, you will actually discover that it's not actually in its proper like binary value, so you have to reverse it. So because uh, reversing it is actually the accurate binary digits of a certain decimal value. Okay, we can actually try it sometime now. Okay, another way, another is parsing. Now this one is actually most common to like uh like in Java. No? So when particularly when you enter data or string, and then into a J option pane, and it's treated as an object or a string value, okay, even if it's numeric. So that is now then the reason why you'll need to convert them, if, especially if you want that data to be used in like in your program. If you are going to use that in a calculation, so probably you'll have to parse them in a either integer, or either in short, or either in double, or either in float. And then by parsing it has to be like read as a token, no, per character in it. And then um, aside from reading the each character in that particular data, the parsing is going to also like doing I mean comparing or making sure that all opening and closing parentheses are actually paired. Okay, and that's how parsing happens. And I mean that's how that's how this stack algorithm parses the value. I mean that this is one of the applications stack can be applied to, in terms of like parsing a certain data, or converting a certain value into another object. Okay, so next is the other this one is postponement, which is the examples that I have given here is the transformation or converting from infix notation to prefix notation, or postfix to prefix, or vice versa, or even evaluation of this infix, postfix, or prefix notations, which are in mathematics we call them as reverse Polish notation. Okay, we will try this sometime in our next topic. Okay, next is the backtracking. So this backtracking is actually applied in computer gaming and decision analysis and expert system. So particularly the goal seeking and eight queens problem. And then we are also going to discuss this in our succeeding topics. Okay, so another application is the stack can be applied to. Actually, when we talk about stack, Java uses two memory management. Okay, the Java uses stack for its primitive type. Okay, and it's Java also uses heap memory for its wrapper classes and its for object. Okay, another example or another application of stack is actually the Tower of Hanoi. The actually the Tower of Hanoi, it's a classic game of like logical thinking and sequential reasoning. It is actually a game where you move brains from one tower to another, but make sure that you follow the rules. It's actually consists of three nods, okay? I mean three rods and a number of discs of different sizes. Normally or usually three discs lang sila, which we can slide into any rod or any tower. The puzzle starts with the disc in a neat stack in ascending order of size on one rod and the smallest at the top. So basically, you are going to traverse all the discs to the other to the other tower or to the other rod by applying certain rules. That you can only remove, no? So parang you can only remove one disc, but you have to make sure that the disc is smaller, and the one that is at the top should be smaller, should be the smaller one in that part. Let's say you have two discs and then you move yeah, you have two discs and then you move the other disc to another uh, tower. You have to make sure that the disc at the lower part or the bottom part should be larger than the upper part. So that's actually like the basic rule in Hour of Hanoi. I have here a link, so you can actually visit that one. So it's where you can actually play game for this Tower of Hanoi. There's a game actually there. No, it's an animated game. Okay, so what are the basic operations of stack? So there are actually three basic operations of stack. Number one is the push, actually two. Okay, so the push is the insertion of a data or an item. The other one is the pop. Pop is, it means you are actually removing data or element from the stack. So push and pop are the two basic operations of stack where you add or you insert and remove respectively or element respectively from the stack. So and it's always going to happen at the top. Again, it's always going to happen at the top. Another operation is stack top. This one is actually going to, it's just an observer of operation where you just have to display the element at the top. Instead of deleting or removing it, you just have to display uh what's the element at the top of the stack. Okay, so another is yeah, here's the push operation. I'm gonna be elaborating this more in our next topic. So we have here tap. So considering we have here the tap. So you have already two data or elements at in your stack. So that's why your tap is now this second element. So every time you insert another data to your stack, okay, using push operation, okay, it will now once it is inserted to your stack as an element or as a data, let's say if it's valid, it's already inserted, it is now then going to be inserted at the top. Okay, so that's the push operations. So your tab basically is going to increment its value upon pushing. Okay, when the tab reaches to the since we implement we normally implement stack into an array implementation. If it reaches to the max value, it's going to to be full now. So once it's full, it's going to display out of array index out of bounds. Okay, so for overflow of element. Okay, another operation is pop operation. This is going to remove data or element from the stack. So basically, if push is going to increment the top, okay, the pop operation is going to uh, de decrease the value of, decrease the value of the top. So basically, because you are removing an element from the stack. So let's say for an instance, you perform a pop operation at this stack. So you have three elements right there, and the top is in blue ones. Okay. After after the pop operation, okay, you you will remove, okay, it will now then remove the data or the element, and then the top now is going to be the second element. So that's how pop operation is doing its process. Okay, so again, I'll be elaborating or giving you more examples on this one. But basically, when we talk about push, it's going to insert and it's going to increase the data. I mean, it's going to insert data at the top, and it's going to what they call this one, increase the the value of the top by one. And then when you are going to pop or when you are going to remove data or element from the stack, it's going to uh, decrease the value of the top, making it yeah, because that's the nature of it. No, the pop operation is going to remove data from the stack. So once it is removed, and if you keep on removing data or element to your stack, once it reaches to like to an emptied stack, it will now then cause an error, something like a underflow error. Okay, so the stack top operation is actually going to just display the value or the element at the top. So it's not going to insert data, it's not going to remove data, it's just going to uh, show the data at the top. Okay, so that's the stack top operation. And these are the properties of the stack algorithm. So number one, upon adding of an element, it's going to be a constant value, big O notation, constant value one. So next is when you delete an element, it's also going to be constant one because again, it knows where to add and it knows when to delete. So basically, it's faster because it knows where it actually store and it knows where it actually delete the data. Okay, so it's just it does not require actually a loop. Okay, it's just going to determine. I mean, it automatically determines the top. Okay, so either you remove or either you add the element. Okay. And then in terms of the accessing, or meaning you are going to traverse one from one value to another value or to throughout the elements of the stack, it's going to be the worst case scenario of the algorithm because it has to be, or you'll need to traverse from the first data to the rest of the data, that particular stack. So that's why it's zero of n or big O notation worst case scenario. Okay, and then there's only one end allows, which is when you insert and when you delete an element, it's always going to happen at the end, which is called the tab. So I guess that would be all for now, and thank you guys for listening. In our next discussion, I'm going to demonstrate a ADT stack using Java language. Thank you guys for listening and watching this video. Bye.